All right, today we're going to talk about vectors. In AP Physics 1, you're going to need to know how to deal with vectors because they show up everywhere, right? I'm calling this unit 0, but because they show up in every single unit, it's really important to deal with, or know how to deal with vectors. If you're going to take pre-calculus or other math courses down the line, you're going to really dive into the meat of vectors. I'm just going to teach you the basics because it's important to know. So, what is a vector? Now, a vector is just a quantity with direction. That's really what it is at its simplest term. If you're driving your car, you're going to see the speedometer, and it's going to say 30 miles per hour or whatever, right? That number is just telling you how fast you're going. That's a size. So vectors, if I'm just going to write this down, they have, first of all, a size. But what makes your speed not a vector is your car doesn't know what direction you're going. It can figure out your speed, it just doesn't know what direction you're going. The second part of a vector is that direction. So they also need some sort of direction. And that's why speed is not a vector. Speed is a scalar, right? So scalar is something that just has size. Don't get too caught up with the vocabulary. I'm just kind of explaining, and hopefully it can make sense, if you're doing it in your day-to-day life sort of thing. But a vector, if I were to draw an example of a vector, let's say I start at this point, right? And I travel to here, right? So my displacement is what we call change in position. I'm not going to talk too much about kinematics or any kind of physics topics, but displacement is just your change in position, and displacement is a vector. So if I were to draw the vector for my displacement, I would just draw an arrow starting here, drawing an arrow to that new point. So that is my displacement vector. I'll call it x. Now, sometimes you'll see this arrow on top. That just lets you know that x is a vector. That arrow on top just means it has direction. It's a vector. Now, remember, vectors have size and direction. Well, what's the size of this vector? Well, it's going to be like that distance from this point to here. So if I were to draw, so x, right? The magnitude, I can notate that with the absolute values. That gives me, 30 meters. Sure, I walked 30 meters. I'm too lazy for that, honestly, but 30 meters we'll just say. The second part is the direction. Well, how do you get the direction, right? You could see the direction is okay, you're kind of going north, if you want to say up is north, and then you kind of go to the right, which maybe is east, kind of going northeast. Mathematically, you would kind of use an angle. So the best way to kind of do it is you are starting at the origin, right? So actually, I'll just draw in the full, I won't do dotted, I'll draw in the full thing. And your direction would be this angle, theta, from the x-axis. So theta above the x-axis. So maybe I'll say theta is equal to 54 degrees, some angle, right? So the way I would name this vector is I would say, I would say something like traveled 30 meters above, or 30 meters, I traveled 30 meters, 54 degrees above the x-axis, or the horizontal, right? 54 degrees above the horizontal, 54 degrees above the x-axis. Doesn't really matter. I mean, maybe your teacher can be a little bit picky about those things. That's how I would name it. Now, you could also say a certain angle sort of away from the vertical. So this angle, if you think about this whole thing's 90 minus 54 is 36, I think. So maybe we could call this 36 degrees. So you could also say 36 degrees from the vertical. I like to do the horizontal, but that's how you would name a vector. Now, how do you do math with vectors? Because let's say we let's say we travel. So let's say we start here, and I end up at this point. Now, sure, I could travel this this length, right? Actually, yeah, let's just start with that is my length. Or sorry, that is my, like, the path I traveled is like the vector itself. Like, I follow this path. And I want to figure out what is my distance. So my distance, I'm solving for size, or I'm solving for the size of the vector. How far did I travel? If this was a velocity vector, size would mean what is your speed. I'm going to deal with distance just because it's more easier to intuitively grasp, in my opinion. Let's get an axis going here. I completely missed the x, but just pretend I'm on the origin here. So I don't know my distance, obviously that's what I'm solving for. What I do know is, if I were to like think of this as like a coordinate, let's just say it's -4, 5. So what that means is, I didn't like actually travel like this, but I essentially went 4 meters to the left and then 5 meters up. So if we take a look right here, 4 meters to the left, 5 meters up, that I didn't actually travel in like a right triangle, but hey, right triangles we can use, like if we imagine that if there is like this x component, I'll draw it separately here, but what I'm basically saying is there's going to be an x component, like a component of your displacement in the x direction, and there's going to be a component upwards. So there's these two kind of vectors. Now 4 meters and 5, in order to solve for your distance, you're just finding the length of that vector. You're just going to do your a squared plus b squared equals c squared. So 4 squared, 16 plus 25. 16 plus 25 is, I think, 41. So it should be root 41. Apologies if I got that math wrong. I don't usually do it in my head. I usually use a calculator, which I don't have right now. But that's really how you find the distance. Now, let's say you want to find the angle. You want to find the direction. How, what's the direction? What's that angle above the horizontal, right? Direction often like presents itself as an angle. The way you could do that is really just inverse trig. So so for example, we know this is the angle we want to solve for, right? The angle above the horizontal. I would just take tan inverse of the opposite over the adjacent, and that would give me my angle. Now, if you're a little bit confused, what is tan inverse and all that stuff? It's really just trigonometry. So I'll show it right here. The tangent of an angle, right? That ratio would always equal the opposite over adjacent. SOHCAHTOA, right? So if I want to take the inverse, if I want to solve for the angle, you would do the tan inverse, where you're taking the inverse. It's like backwards almost. Opposite over adjacent equals theta. So what you could do is just plug this into your calculator, and boom, bada bing, you could solve for that angle, which is the direction. And I don't know off the top of my head. I don't have a calculator. I would guess it would be, it would probably be more than 45 degrees. But yeah, I'm not too sure what it is off the top of my head. And you can use a calculator to figure that out. So last thing I'll kind of leave you with is, now let's say, and I'm going to go into forces here, and if you're not on forces, that's okay. I'm not going to go give you a crazy problem. I'm just going to show you how you would solve a problem like this. Let's say you have a box, and let's say someone pushes it up 30 newtons. A newton is just a unit of force. You don't have to worry about it if you haven't gotten there yet. 30 newtons up, 15 newtons this way. What is the total, what is the how would I say this? What is the net force on the object, right? What is the total force on this object? You can think of the net force, total force. And what you're really solving for is like, yeah, you got to add these two vectors, right? Because whatever these two vectors add to is going to be the answer. So, sorry for my dad laughing. He laughs a lot. I don't know, he's a laughing guy. Wow, he's talking really loud. Okay, hopefully it isn't too distracting. Now, a common mistake is people are like, well, I got to find the total force. 30 newtons plus 15 newtons, 45 newtons. The thing is that is scalar math. That's how you add scalars, when you just have size. But with vectors, you can't just simply add 30 and 15. The reason for that is because they're not in the same direction, right? Sure, there's 30 newtons and 15 newtons, but that 30 newtons is upwards, and that 15 newtons is to the left, or whatever. Or right, you're right. Sorry, I might have said left. They're in different directions. They're directed in different directions. It's like an easier way to think about it is, what if this 30 newtons... Oh, wait, no, that's actually not an easier way to think about it. But, like, it's this 15 newtons is contributed this way, this 30 newtons is contributed that way. You can't add up different directions. You would have to find you would have to manually kind of find the size and the direction. How you would do that is you would use like I'll actually explain in a second how you would do it. But what I want to show you is that intuitively, you could probably imagine that vector that's like the total force is probably, sorry about that, let me add back the 30 newtons. I'm sorry about the laughter. It would kind of be like this. It would be like a combination of the vectors this way. So this way plus, right plus up is going to get a diagonal vector. And the way you would solve for that diagonal vector, right, the combination of the vectors is you would just do right triangles, right? So if this is I have 50 newtons this way, and the 30 newtons is upwards. What I can do is I can kind of move it here, right? And this is just to help me solve for my final answer. And then I'm solving for the combination of these two. And if you know tip to tail, once you get to pre-calc, this will make a lot more sense. 30, so you're solving for the direct size. 30 squared plus 15 squared is going to be, I have no idea, 900 plus 225. I don't know what that would equal, but that would be your size, and then you can plug that into your calculator. Now, you solve for the size, you still got to solve for direction. This is where you use your inverse trig. Let's say I can find the angle above the horizontal, right, above the x-axis. What you would want to do is inverse trig, and that would solve for your angle. So hopefully this kind of helps with vectors. There's a lot of stuff you can do with vectors, but I think adding vectors is something you're going to do a lot in this class. So it's good to learn that sort of foundation. Oh, I don't know why I'm walking over. I'm going to actually edit this out. See ya. Thank you for watching.